Dr. John. And today we'll be going through the tensor flow operations that we have, the tensor operation in INSUM. So using this TF or constant, we can create constants. We can also declare constants as array. So here we have an array, and we have the constants basically declare them as tensor array. For instance, in 2D, look something like this. The shape of this tensor is 2, 3. And using this, we can convert tensor into numpy. So x dot numpy will convert it into numpy. We have ones and zero fills it with 0 and 1s. The shape equal to 2, 3. It is creating a tensor of 2, 3 dimension with zeros and with ones. So we have variables, and tf dot variable initialize the value for variable. We can also change the tensor variable. We have math in tensors, so we have something that is random, not normal. So it will select normalized values randomly, and this is how we can perform addition in tensor, and we can square a tensor, and we can do exponential in tensor. Computing gradients with gradient tape. So here we are trying to compute the gradients. We'll also perform end-to-end linear regression. This is one example where we have regression function. We are calculating mean squared error here, and we're calculating computing the prediction. We're calling this compute prediction over here, and then we compute loss as well. Taking mean, and this is how we can perform. This is what the plot is basically of the regression that we perform. So we are trying to create a data set. So we create a tf.data dataset object for easy batch iteration. And now we're running the code fast with tf.function. So previously it was taking some time, and now it has reduced um, by 1% margin kind of thing. And here we have custom linear layer, and then we have non-printable sum layer function, and then we have custom lens layer. This is a neural network that we were creating, I think. Yeah. Once we're done with that, we have some INSUM operation. We can do matrix multiplication. We can do sum of result all elements, so it will sum of all the elements with np dot sum ij, and column by sum. This will result in column by sum. This will result in row by sum. This will result in outer product. This will result in diagonal extraction. So basically, this is a shorthand method in performing matrix multiplication in tensors. Um, this is like the element-wise multiplication and summation of element-wise multiplication and different ways of performing different operations. Now let's go to Pytorch. We'll begin with installing the dependency. Then we have some tensor constants, how we're converting tensor to numpy and other things. Now we're creating tensor for specific shape, moving the tensor to GPU if it's available. And after that, we're training a loop where this is an example training loop. And once we're done with this, we'll create a data set, load it, we initialize the model, and then we're good to go. So this was a loss. This is the training completed, and we were performing gradient descent. Now it's the time to perform end-to-end linear regression in PyTorch. And yeah, so we have synthetic data, and over that data, we're making a training loop, and the batch loss has reduced a lot when we have started using tensors in PyTorch. And time per epochs also got reduced to 0.194. That is not that significant, but yeah, still significant. We created some custom layer, and then this is some operation in PyTorch. That is for this video. I hope you learned something out of this. Thank you so much for watching.